Good afternoon. I would like to tell you a few words about the Egress from car parks and other fire outcomes used in risk assessment. Especially, first of all, we have to answer ourselves one question: why we are doing that, and how we are going to make the assessment of our system and its quality. And all over the world, and we first of all we have to save the lives and health of people, and the construction of the building and the rest of the materials which are inside. So here I would like to focus on people evacuation, and I would like to present you two ways of analyzing it. First one is the typical engineering method, which is usually used during designing process, and it's quite popular and usually used. And the second one is that which we perform here in this project. It's some kind of an statistic analysis. So first of all, the main evacuation factors are assets, so available safe egress time, and RSET, so required safe egress time. So first of all, the required time is the time which we need to keep the egress free of smoke, temperature, and toxic gases, to keep it free and let people to evacuate. And another parameter is the available safe egress time. So this is the factor which focus on that how system or fire ventilation system is working, what are the performance of the environment during the fire in the building. So first of all, we have to calculate these two factors, asset and RSET. First of all, the RSET consists of few parts. First part is part from ignition to fire detection time, so it lasts. Sometimes it can be few seconds late or a few minutes. It depends of the fuel which is being burned. After detection time, we have got time to verify the alarm if it is not a false alarm, if it is the real one. So the system is going to restart a few times and check if it is real fire. Then we have got fire alarm, and we have got time for pre-movement time. So this is the time for reaction, people reaction. And after that, we have got that small part which is from the time of reaction. We have got movement time, and after movement time, we have this is the time from the reaction to the moment when people are in the safe position, in a safe fire zone. So this is the RSET time, so that required time, and the required time has to be smaller than available time for safe egress. So, and when we have got these two parameters, we can say if asset is bigger than RSET, that we have got safe system. How to assess the available safe egress time? So we have to define some critical parameters of the environment during the fire, and these parameters should be divided into parts of a fire: evacuation time and time for fire safety brigades. So during the evacuation time, we have to compare the parameters as temperature, smoke, and radiation. So the temperature of the hot gases layer shouldn't be higher than 200 Celsius degrees, and the temperature at height of 1.8 meters shouldn't be higher than 60 Celsius degrees. About the smoke, so the density of smoke shouldn't be bigger than 0.1 grams per cubic meter. It is visibility around 10 meters, and the radiation shouldn't be bigger than 2.5 kilowatts per square meter in the direction to the floor. This is the this kind of radiation is safe for people during the evacuation time. And the second part is the are the parameters, are the critical parameters of the environment during the fire brigade activities. So the temperature can be higher, and it is measured on the level of 1.5 meters from the floor, and it can be around 120 Celsius degrees because of the because firefighters have got different clothes and the different ways of carrying out of breathing ways. The radiation can be bigger. It can be even 15 kilowatts per square meter in the distance of 5 meters from the fire, and 5 kilowatts per square meter at the distance of 15 meters from fire. So it allows fire brigades to come quite near to the fire source and to extinguish it. And of course, another question is access to the fire source, some kind of ventilation systems, some kind of a situation with the wind direction led us to have the situation that fire source is that the smoke layer is fully controlled, so fire brigades can easily have the access to the fire. But first of all, to calculate the required time, to calculate the available time, we have to make some kind of an analysis of the evacuation time. So we have got two ways. One way is an analytical one for some simple cases, and the second way is to make some kind of a numerical calculation, as you can see here. But what I would like you to look at it, we have got here the one of the levels of the car park. That one on the left is fully covered with the cars, so we have all the locations of cars are filled. And the picture on the right side, this is the car park without cars, but we have got the same amount of people. And when we start the calculation of evacuation, and if we compare both times, you can see that the time time of evacuation in car park with cars and without cars is more or less the same. So it's only 3 seconds of difference. So, but we have to remember that in car parks we have got quite huge area, quite simple way of evacuation. So the time of evacuation is not such a big problem. And it doesn't depend so much of the amount of car parks which are in the car park. Here you have got the situation with the car parks where you have got 10% of cars, 30%, 50%, and 100%. And if you compare all these calculations, the difference between first case and the fourth case is only 12 seconds. So the time of evacuation in car park, when we analyze it, and when the time of evacuation in car park doesn't depend so much of the amount of people and of the amount of cars inside that area. But there is one thing which can involve very much for the evacuation time. It's the possibility of the amount of the doors where people can evacuate. So, for example, on the pictures on the left side, all the doors are possible for evacuation. On the right picture, we have got 2 doors switched off, for example, because of the amount of smoke, and so it's not possible to evacuate using these doors. And if we compare these 2 times and these 2 simulations, as you can see on the right one, all people have to go to the third doors, so there can be a situation that there are some kind of queues and the time of evacuation is longer, as in the situation for example, in the office area or in the auditorial area, where of course we can have got some kind of influence of the wind on the building facade. But if we compare these simulations with the car park simulation, here we have got more or less the same similar situation when there is a lack of the doors in that area, and There we can find some kind of queues which increase the time of the evacuation time. The same situation we have got here in the office area with some kind of an open space and small offices, and on the right side with the situation we have got where we have got auditorial area. People are staying in the queue to get out from that area where we have got fire. So this is the first way of analyzing the system, if it is safe or not. And that what we would like to present is that what was done in that project. These are the statistical analyses. So not only asset and RSET are the only methods to analyze the safety of the system, but that what we proposed is to combine four variables to compare smoke concentration, so the visibility, to compare temperature, flow velocity in the cross section of the car park, and number of the roads available for fire brigades. So if we take these four variables and compare them, we should receive an answer how the system works and what is the risk of that if the system is working properly or not. And how we did it. First of all, the first step are the smoke mass concentration and the visibility. So we defined that our acceptance concentration is 0.08 grams per cubic meters, and we defined that if the smoke is, if the car park is filled in less than 30% of its area, the system is working properly and it's good. Between 30 and 60% of the area of the car park, the effectiveness is average. If more than 60% of the car park is covered with, is filled with the smoke with the density bigger than 0.08 grams per cubic meter, the system is not working and it's not acceptable. Another parameter is average temperature on the level of on the height of 2 meters above the floor. So if the average temperature is less than 100 Celsius degrees, the system is good. If between 100 and 120 Celsius degrees, it's acceptable. But if the average temperature on that level is higher than 120 Celsius degrees, the system is bad and the situation is unacceptable. The third variable is the average velocity in a cross section. So as you can see here, we have got three ranges of velocity in the on that level. If velocity is less than, if average velocity is less than 0.9 meters per second, the system is the situation is unacceptable because the velocity is too low to push the smoke outside the car park. The acceptable flow velocity is between 0.99 to 3 meters per second, and if it is more than 3 meters per second, it's too much because of the risk of increasing the heat release rate of the fire. And the fourth variable is the access rules for fire brigade. It is defined as to verify how many ways we have free of smoke and temperature, which allows firefighters to come and extinguish the fire. So if we have got if we have situation that there are possible, sorry for Polish words, if we have got three ways for fire brigades, the system is working very good. If there is only one way, it's acceptable. If there is no ways for fire brigades, the system is unacceptable. So summarizing all these variables, we can define something like an operational uptime, so which defined in the percentage in how many days during 1 year the system is working properly, and it's a sum of all these 5 variables, so the smoke concentration, the velocity, temperature, the amount of the routes for fire brigades, and of course the external influence of the wind. External influence of the wind on the car park. So, and another part of this presentation, I think I will give